picking up where I left off. All right, it's kind of weird to teach to an empty room. Let's see. So let's say we start off with a log. My first step would be to switch x and y. So I would have x is equal to log base 2 of y. And then to get the y by itself, I have to rewrite the log in its exponential form. So here's one piece, here's another piece, and here's the third piece. So this would be 2, base 2. Now, a log is an exponent, so the x goes there, and then it equals y. So that would be your inverse equation. Then you can answer the whole domain and range question from this because it is the exponential part. Domain is infinity to infinity because it comes from the exponent, and range is sort of the result. The y value is the result of the 2 to the power of x. So that will always be positive, so the range is from 0 to infinity. It will never actually be 0. So let's try a couple more of those that have some transformations going on. All right, first step, switch x and y. So x is equal to natural log of y plus 7. Careful here, the y and the 7 are not really attached to each other. The y is inside the natural, like it's attached to the natural log, but the 7 is sort of outside. So I can go ahead and subtract that over first. So now I've got x minus 7 is equal to the natural log of y. And now I'm ready to rewrite this. Here's one part. Okay, so the e is one part, the y is one part, and the x minus 7 is one part. So this would end up being e to the power of x minus 7 is equal to y. Then when I go and do my domain and range, let's see here. Domain is easy because it is the exponent. Range will be a little bit harder. It will come from the result of doing e to the power of x minus 7, which will always be positive. Yeah, it'll always be positive, so 0 to infinity. For this one, there are both x changes and y changes. If we start off by switching x and y, we're going to have x is equal to log, and this is log base 10, of y plus 3 minus 6. Let's move that 6 first. So we've got x plus 6 is equal to log base 10 of y plus 3. And then here are my 3 pieces. I've got the 10, the y plus 3, and the x plus 6. So rewrite them, and it becomes 10 to the x plus 6 is equal to y plus 3. And then I do need to kind of move that 3 over. But that 3 is not going to impact that exponent. It's going to be kind of after that, like this. So this is our inverse equation. Domain and range. Domain is easy, negative infinity to infinity. Range will be harder, right? Because the y is equal to comes from this thing, take away a 3. Well, this part is always going to be greater than 0, but then we're going to take away 3. So my range is negative 3 all the way up to infinity. Because I'll start with a negative 3 and then I'll always add something to it, something that's positive. All right. We talked about the log graphing in a previous video. I'm just going to recap and show this in case that video didn't save. There's our basic shape of the log graph. Every log has a vertical asymptote at x equals h. And then we talked about making two easy points. The easiest points to create are at the base value, because it gives you an output of 1. And if you choose a 1 for your x value, it gives you an output of 0. What that means is not that these are going to be the points you plot. It means start with these points. If there's an h, change the x's by that amount. If there is a k or an a out front, change your y values. So you can kind of see that here. Since this was a base 2, I started off with a parent table, 2, 1, 1, 0. This was a movement 3 in the x direction. It told me that my asymptote was at x equals 3. So I started there. I graphed the asymptote. Then I added 3 to each of my x values, and then I plotted my 2 points. I know what my general shape is, and so I connect the points. For this last one, there are 3 different transformations. It's a base 10 log, so I started with the base 10 parent graph. Then I did my x change first, so I moved my asymptote 6 left, and I subtracted 6 from each of the x values. Then there were 2 different y changes. You need to apply both of those to the y's, and the order does matter. The multiplier comes first, then the add subtract comes second. When you plot those points, you may struggle with how to connect them, so think about physically what are the changes to the graph. This had a vertical flip, this negative out front, so that's why it's coming from the top and then growing away from the asymptote. All right, that's log graphing and inverses for 9J.